Hey there. So we are going to fill in our density activity today. For this activity, you are going to need a couple of different colored pencils. I have chosen orange, green, dark blue, and light blue, as well as brown. So please make sure that you have those five colored pencils so that you can do this activity. So Um, the directions tell me the label lists the density for five different liquids. How would they layer on top of each other if they were put in a beaker? Cut up the table and the beaker, label and color the layers of liquid in the beaker according to density. This actually fits perfectly into my notebook without having to cut each of these out. So I'm just going to leave it like it is, and I'm going to tape this in when I'm finished. So I'm going to do the first thing, and I am going to label and color the layers of the liquids according to their density. So if you'll recall, density is simply a measurement that reflects how much mass takes up a certain amount of space. It's simply, so a substance that has a high density simply has more mass in a given amount of space versus a substance that has a very low density, right, has less mass for that given amount of space. So we can see here, right, we've got our substance and then we have our different densities. So the higher the density, right, the more mass. So I'm going to take a look, and it looks like, right, my highest density is going to be honey. So 1.42 grams per centimeters cubed. So I'm just going to use my pencil. I'm going to draw a line right here, and then I'm going to label this as honey. So got that one. And then my next most dense substance is my water. So I'm just going to draw a line. That wasn't very straight, but that's okay. This is water. After that is my, oh gosh, look at that. I messed up because this is 1.3. Haha, I'm going to add salt right there. Look at that. I caught my mistake. Perfect. All right, so salt water, because that's 1.03, right? And then water was just 1. So that's my bad. So salt water, and then just water. Aha. And then I have rubbing alcohol and salt. So soap, right, is more dense than rubbing alcohol. So here's my soap. And then finally, my lowest density here, which is our rubbing alcohol. Perfect. And then I'm just going to color this in. So I'm going to use my orange, and I'm just going to lightly color in the honey. I chose orange just because I feel like it. All right, and then my salt water, I'm going to use my kind of darker blue. But again, I don't want to make it too dark where I can't read what I wrote. Okay, so there's my darker blue. And then for my water, I'm going to use my light blue. There we go. And then for soap, I'm going to use green. There we go. And then finally, for my rubbing alcohol, I'm going to use my brown. And again, I'm just going over it very lightly so I can still read my handwriting, right, what I wrote. So there we go. So that's first part of the activity. Right? Second part, ice has a density of 0.93 grams per centimeters cubed. If you place an ice cube in your beaker, where would the ice cube fall? Draw the ice cube in the beaker, compare the density of liquid water to the solid water or ice. So we know that the ice cube, right, has density of 0.93. So if I look, right, that's actually the same density as my soap. So I'm going to draw in my ice cube here with my pencil. I'm basically just drawing in a square, right? So I can label it ice. That way, if I forget, I know that's what I'm looking at. And then, so that's where the ice cube would fall. So draw the ice cube and compare the density. Okay, so we're going to write out a little bit of stuff here. So the ice cube will be suspended in the soap layer because soap and ice have the same density. Now, comparing liquid water, right, to solid water, right, we see liquid water, right, has a density of 1, whereas the ice, right, had a density of 0.93. So ice has a lower density compared to liquid water, which is why it is not found in the same layer as liquid water. So again, if density is a measurement of right mass that takes up a certain amount of space, right, we have less space with our ice than we do with our water. So ice has a lower density than liquid water. So there we go. So this completes our density activity. And again, I just kind of wrote all of this on this paper. If you cut yours out and you just wrote this on your notebook paper, that's fine as well. But I'm just going to grab a piece of tape this in, and I'll be good to go. So hopefully this helped to kind of explain density a little bit more. If you still have any questions or concerns, just let me know.